right, let's move down the stack there. They had that great slide about the Yellow Brick Road. We're moving down towards the renderer side of things. So that's a cool way of looking at it. So let's just jump in here and talk about what MapLibre is. So MapLibre is the inheritor of the Mapbox GL APIs. Essentially, when Mapbox went closed source with the newer versions, MapLibre stood up and took those, forked off those versions and made them their own, and it has been since trying to organize all of the updates and maintenance and so on around that. So it's a worldwide organization. Anybody can join, anybody can contribute standard open source stuff. I find it to be kind of heavily based in Europe with a lot of corporate involvement in the US, but I think that'll grow over time. So it is responsible primarily for two map SDKs. So you got the MapLibre Native, which is what we'll be talking about here, and the web version, MapLibre GL. So that's the API for web browsers. You've probably seen that one around slightly more. The web version is doing quite well in terms of participation. There have been features that have been released, new stuff's come out. People are participating in that, adding bug fixes and so on. Less so on the native side, and there's an interesting reason for that. But you can also see, as is typical in open source geospatial, the web stuff tends to be a lot more popular, even though maybe the native stuff has a kind of a wider end audience. There's just a lot more developers on the web. So MapLibre Native has one big problem, and this comes from a history lesson of technology you might not be aware of. It's pretty straightforward. In the olden days, we used to use OpenGL ES on both Android and iOS and Mac OS as well to a certain degree. And then Apple came out with Metal, their own API. It's Apple, they do stuff like that. And then they deprecated OpenGL in 2018. So it's actually been deprecated for a while. And what that means is always a little ambiguous. What it means practically speaking is that whenever you compile something that uses OpenGL, you get thousands upon thousands of warnings. So it's kind of annoying. But it's also a little scary if you're a product manager. Imagine you're using OpenGL, an OpenGL-based product in some sort of service that brings in tens of millions of dollars. What are you going to do? Is Apple going to take it away from you? Is it not going to be supported on new hardware? It's Apple, nobody knows. So this is a huge piece of technical debt that the MapLibre community had to address. So what do you do about that? So you've got this low-level rendering SDK for real-time, basically real-time display. Do you do a real-time translation layer? There are some of those out there. Problem with that is it adds a lot of size. And native developers are very sensitive to size of toolkits. Do you transliterate the shaders? You could translate them from what they're currently in over to something else. Yeah, maybe, but there's a whole lot of plumbing around that that's still missing. Rewrite it all from scratch. That's an option. In Rust, why not? So those are all valid options. Or do you just hope for the best? That's actually what most developers have been doing, is just kind of waiting to see what happens. Or we had this saying when people would get too creative in an old company of mine, you really need to think inside the box and just implement Metal. So that's what they decided to do. So the first thing was making a plan. And Stamen knew all the right people here, so they kind of did the community engagement process. AWS had the money. They roped us in to do the planning for the geospatial rendering. This is my company, Wet Dog Weather. And of course, MapLibre provided a lot of feedback as to what they want. So there's an interesting footnote here. We're a weather company, so why are we doing this? And the answer is, well, money. And we have the capabilities. In a previous company, a couple of us used to do this open source toolkit called Whirliglobe, which made the transition from OpenGL to Metal. So we know how to do that. And that's how we got roped in. So the first thing was the plan. But rather than just fixing the one thing, you never want an opportunity like this to go to waste. There's a lot of other technical debt around the renderer and MapLibre. So we looked into what else we could fix kind of at the same time. Now, I went looking for this quote, and I found it attributed to Rahm Emanuel, who has an interesting reputation these days, but he seems to have lifted it from Winston Churchill, who also has kind of a similarly interesting reputation. So I think it's got a nice amount of ambiguity to it. So the first part of the plan that we put together was to modularize the render, which is, say that 5 times fast, it's great fun, to essentially break it into pieces so that we could first kind of lift it up, fix the foundations, and then put it back down on those foundations. And then I guess swap out the foundations for metal. So the main goal there was simplifying the task of adding a new rendering SDK. This stuff is not easy. Maybe there are projects out there which have already failed to do it. There's a lot of interesting rumors. And while we're at it, we wanted to modernize the renderer. This renderer, MapLibre isn't properly a geospatial renderer. It's more like a really clever map toolkit that knows how to draw itself. A renderer would be something like Unity or something of that nature, which is flexible and understands that if you give it too much geometry, it breaks it into pieces and all this other stuff. So we wanted to modernize the renderer to follow more of a 2023 pattern as opposed to when this was written. The secondary goals were basically to give something the team to work on that was a bit lower stakes than actually getting it over to metal, get everybody working together, warm them up. And then, some specific goals like allowing for shader replacement. These are the programs that actually draw things. Allowing for replacement of layers. So let's say, for example, you wanted to change the way that roads were drawn. Right now, that would be very, very painful. We'd like to be able to say, hey, I got a new road drawing piece of functionality. Can I just kind of put it in there? And ease of adding new core functionality. The way a good open source project works is that people will kind of use the hooks you provide to add a new piece of functionality. And if you like that, then you can kind of pull it into the main core toolkit. That's a better process than them having to crack open the whole thing and figure out how it's all intertwined. So the second part of the plan was doing metal, obviously the whole point of the thing. So metal is a little bit different than OpenGL, and it's got different modes. There's direct mode where you basically take we never have been saying draw this polygon for quite some time. What we say is draw like a whole bunch of polygons at once, really triangles. Direct metal rendering is the closest thing to OpenGL where you say, okay, draw these polygons and then draw these, change a bunch of state, draw these others. The way people really do it these days on modern GPUs is indirect. You set up all those instructions and you just pass in the GPU and then you don't mess with them. So GPUs have gotten that is the graphics part of the system has gotten very intelligent and they need to be fed in certain ways. And that's actually a lot of the problem is that MapLibre Native doesn't feed the GPU in a way that it's expecting, so it's a lot slower than it could be. And then we also wanted to move as much of this logic to the GPU as possible. If you're looking at one of these Slippy maps, you might think the parts that are changing the opacity on the fly, like as you zoom in, things get less opaque, or changing the width on the fly, most of that's going to be done on the GPU, right? That's stuff that a modern GPU can handle. Not so much in MapLibre Native. A lot of it's done on the CPU, and that causes a lot of not conflicts exactly, sort of choke points. And we wanted to do as much threading as we can manage. Threading is very important on modern mobile devices. All right, so the second thing, after the first thing was make the plan, we did that, finished it early this year, and then the second thing was implement the plan. So this was an engineering project. So Stamen kindly stepped aside and we took over management. And basically the way it works is that my company, Wet Dog Weather, basically me does the engineering management, two of my people participate in the development, two of the AWS people participate in the development, and we've got one guy from Meta. Like I always want to say Facebook, it's Facebook to me. And then we have two maintainers from the MapLibre community. Those guys, basically they're paid maintainers now. So they're getting up to speed on maintaining this toolkit into the future. Everything we do is going to be handed over to them. So one of the goals for this was multi-SDK support. And SDKs here, we're talking about just like the rendering part of it. So we still have to support OpenGL ES, more modern versions of OpenGL ES, but it's still the same. Android requires that. We have to support Metal for iOS and macOS. And then we kind of get some support on Linux and Windows for free through a translation layer. But at some point, you might want to support DirectX if you're Microsoft. And then optionally in the future, Android has its own transition going from OpenGL to Vulkan, but that's a very slow transition. Nobody can make anybody doing anything on Android. So it takes a lot longer. There's good things about that too. So we want to create a structure where we can plug in the new Metal stuff, but other people can come along and add Vulkan, add DirectX, or just do a really nice OpenGL implementation better than the one that's there. We want it to be user serviceable. So I typed tangled thicket of metaprogramming into DALL-E, and this was kind of my favorite output. If you're not familiar with metaprogramming, that means templates in C++. And other things in other exotic languages. And that's a good description with the rendering engine. It is very cleverly built, not a lot of comments, and difficult to disentangle. So what we'd like, oh, thanks. What we'd like the maintainers to do is to be able to upgrade to new versions, have some clue of what's going on, and basically, as we figure out what these things do, leave little notes for them to explain it. We'd like it to be upgradable. So an open source project, ideally, as well as using it, because it's pretty easy to use, it's just MapLibre Native, people use it. In addition to being able to use it, you want to be able to upgrade it. If you have some cool new idea for a feature or something that you have to do, you'd like to get your hands in there and implement it. So you want to be able to replace the existing shaders, for example, add new shaders that do something entirely new, replace the existing layer. So let's say you have a better way of drawing roads, which given how old the road drawing part is, you probably could. You could do it all on the GPU and do some really cool stuff. So it would be nice to be able to replace that as a piece of functionality, as a module, without having to rip out the existing stuff. Just kind of flip a switch and use yours. Add new layers, and we'd like to have some training examples. Just to give you an example of the problems with current upgradability, if you take the current version, all the shaders are in this compressed blob of data, which when it needs one of them, it just pulls the data out, uncompresses it, and compiles it. That's incredibly clever, very difficult to maintain though. Multi-threading is another goal for kind of the late part of the project. So there's already some geometry working on the threads, but when this was written, these devices didn't have that many cores. Now even the cheapest Android device has a significant number of cores, and you really want to take advantage of that. And the etiquette for a toolkit like this is you should do the bulk of your work off the main thread and let the developer have control of that main thread, that main CPU, and kind of do your work off to the side in order to back it when you're ready. So that's something that we're hoping to attain as well. It's actually easier to do in Metal because of the way it's structured. You can do it in OpenGL too, but it requires more work. So how's it going? We are almost done with phase one. Took a little bit longer than expected because, of course, it took a little bit longer than expected. It turns out that data-driven styling is very complex because things change a lot per frame. And they had very cleverly done the metaprogramming sort of combined with that to produce code which is very specific and very fast, but difficult to disentangle. So a lot of the first phase was just understanding how that worked, and we understand it now. So we'll wrap up that first phase here at the end of the month and move on to the next. So we should have a Metal version sometime this summer, and then we'll work on the more advanced Metal versions and threading and so forth. So one big problem with this is MapLibre is not a lot of fun to develop. So one bonus goal we had was it should be fun to add something to MapLibre Native. The JavaScript version is pretty good. People can add new features. They can kind of stick. JavaScript has that nature where you can stick your code in the middle of it and do something new, and it's quite good that way. Sometimes bad, depending on how you view it, but it's very flexible. We want to make it more open so that people can add their own functionality. They can start looking into AR, start using it for true 3D if they want to. We're basically trying to make it easier to add new pieces so that somebody can come along, have a cool idea, and at least get something basic working fairly quickly. That's necessary, I'd say, for the long-term health of the project. This needs to be something that attracts volunteers who turn into developers, who perhaps make it their career, and they add to it. It's a good process that you want on your open source project. So we'll wrap up the development by the end of the year, and we'll see where it goes from there. So it looks like I've got a minute to spare. Any questions?